And therefore, as a free man, I take pride in the words, Ich bin ein
Science! Science!
I know the human being and
Science!
can
Science!
coexist peacefully.
This was thou findest.
Folks, this is Petri Dish. I'm Nathan Allen, and I'm joined here by Sean D. Allen, PhD.
Hey, everybody.
And today, we're going to talk about some really, really wacky creatures. We had a lot of fun talking about animals in a couple of different contexts, and I asked Sean, hey man, we got to up the game. We got to talk about really extreme things, living creatures that are totally different from us. And Sean comes back and he says, Nathan, there's this thing.
Yeah, I was like, hey, Nathan, why don't we talk about extremophiles?
You gotta explain this one to me, Sean. What does it mean to be philic towards extremes?
Yeah, man. I mean, you practically broke it down yourself. Extremophiles are living creatures that like to live in extreme environments. So we're talking about deep in the water where it's dark, there's no sunlight, or even deeper where pressures are super intense, lava flows, tundra, outer space. And so those are all the kinds of extreme places that really drive animals to adapt to be able to survive there.
So guys, we're gonna survey those locations. We're gonna survey the crazy ass shit that lives there. And big themes, we're talking about this because all the adaptations these animals have, we can use that to genetically modify ourselves for deep space travel or climate change, right? I'm just trying to give context to the people.
Wow, fuck, okay.
Like Hyperion, right?
Yeah.
Like we can be spiky.
You know what? Let your dreams, fucking guide you.
Okay, guys, I'm going to let my dreams guide me. We're about to spend the next 45 minutes or whatever talking about extreme animals who can actually bend space and time to live in deep sea vents.
What the shit?
Okay, Sean, so environment 1. What's our first crazy extreme environment?
We're going to talk about the briny deep.
Is that like a SpongeBob SquarePants reference?
I don't know. Is that something they say in SpongeBob SquarePants?
Briny sounds like a joke word to me. What is the briny deep?
A briny is like salty. I'm just talking about salty ocean.
Oh. Okay.
It was cool sounding.
So wait, what's extreme about the ocean, though?
Yeah, so there's basically a whole chunk of the ocean where the ecosystem is driven by the fact that there's light coming in, right? Ooh. So you start out, you have light coming in, and you have algae and phytoplankton and all these dudes.
This is like normal ass ocean.
Right.
Yeah.
You got normal ass ocean, and then the sort of food web is constructed around these things that are bringing in the light and turning it into food for other stuff, right? But then there's the rest of the ocean.
Okay.
The dark parts.
The darkness.
Okay.
Darkness.
And there's this region of the ocean, which is different kind of zones of the ocean are called different pelagic zones. And so there's the bathypelagic zone, which is like about 1 to 4 kilometers down. And down there, basically, at that point, there's not really any light anymore. Or it's super dim.
1 to 4 kilometers doesn't sound that far. How isn't Everest 4 kilometers tall?
Jesus, is it 4 kilometers tall? I don't know.
I was kind of setting that up as a gag. It's really not, right? Isn't 4 kilometers like into space or something?
Well, okay, so it's definitely, it's both true that when we're going across the Earth's surface, like people run 5Ks, right? So
I don't.
I've
never run that.
That's true. I watched you eat 3 McDonald's sandwiches in a row today.
Don't burn me. Don't tell the people that.
You should jog a 5K sometime. It's fun.
How did this happen? Shut up.
Well, no, okay, but a 5K is like only like a little bit more than a couple miles, so it's like not even that much, right? But going 4 kilometers up in the air or down into the ground is a considerable distance.
That's a long hike.
Yeah.
I mean, I'm wheezy after a flight of stairs.
Yeah, man.
You just like vomit out a McChicken.
Well, one of the things that happens as you go deeper and deeper underwater is the pressure builds.
Oh.
Right? So you actually have really considerable pressures that start to build up to the point where, there's a certain point where human divers can't go any deeper, and then we start to have, all of the ways that we see stuff in the deep ocean is
like
with like
James
remote
Cameron
controlled
shit.
Yeah, exactly.
I'm gonna ask you a really stupid digression question, but it's really important.
Okay.
What makes pressure? Like, why is it more pressurized down there?
Yeah, okay. So pressure is force over area. But the idea is that
Sounds like a Stallone film. Force over area. It's just him lying down on people. Whoa.
So most of what we feel as pressure is about our environment pushing on us. Okay?
Why is the environment pushing on us?
Oh, yeah, because under kind of our normal surface levels, there's just gravity.
Okay.
And gravity is kind of keeping gas around us at a certain level, and that gas is moving around and hitting us.
Okay.
And so there's a certain amount of pressure we have because of that. As you start to go underwater, what's hitting you is water molecules.
Oh, interesting.
And as you keep going deeper and deeper, you have the weight of all of the water molecules in a column above you.
Right.
Kind of weighing down on you.
Okay.
And so that's what causes the pressure, is as you go deeper, there's more water above you pushing down.
And I see something really interesting here, that proteins start to denature at pressure as intense as the deep sea.
Right. So this is something that really surprised me. Proteins denaturing is basically them losing their shape.
Right.
Okay. So proteins in our body, all the guys that run around doing stuff, once they lose their shape, they can't do their job anymore. And proteins denaturing is one of the reasons why, like when you cook an egg, the egg whites kind of solidify and change their color. It's a denaturation process. It's why if you heat milk too fast, you can like curdle milk, right? That's also proteins denaturing.
Right.
So heat is a really obvious way to denature proteins. What I guess I didn't realize, but probably should have been obvious to me from a physics standpoint, is that really intense pressure pushing down on a protein a lot can also make it so that it kind of squeezes out of shape in weird ways.
That makes sense. I mean, like, literally, it's a chain of different elements and bonded together. A lot of pressure is going to make it go wobbly wobbly.
Yeah, I mean, this is one of those things where pressure seems like a big scale thing to me, like that happens to like animals and people.
Right.
And it's something that
happens on the string quantum level.
like when we get down to like the molecular level, it's hard for me to think about molecular pressure, but it's a thing. And it can mess up the protein structure.
All right. So we're getting down. We're going down to the ocean. We're getting into all these pelagic babes. The pressure's intense. There's no sunlight. So nothing lives down there.
So, I mean, that's the really cool thing, is that a long time ago, it was kind of assumed that nothing could really live in those dark areas.
Until the nature documentary last year, The Meg. It turns out Jason Statham lives there.
The Meg turned it around.
Yeah. So go. I'm in the abyssoplastic zone.
So basically, one way that you can get energy down there is through something called marine snow. And what marine snow
But
is...
isn't it water? How do you get the snowzes?
Right, it's not water snow. It's the snow of organic matter. Decaying carcasses.
So
and
like
stuff
dead
that.
shit that's been so finely grained that it looks like a snow, kind of.
Grained, and also like, you know, some of the things that die are really small. Right, like when plankton dies, it doesn't need to break down any further to look like snow.
Right, sure.
That shit already looks like snow. So basically, a bunch of dead stuff floating down from the light areas of the ocean into the dark areas of the ocean.
That's fucking
is
horrifying.
a major source of food, and that
Jesus.
that starts the food web down there.
Jesus.
But there's also deep sea vents, and deep sea vents do not need marine snow to get energy because they get their energy chemically out of the actual vent that's coming out. But we'll get to deep sea vents a little bit later.
Wow.
Yeah, so, you know, one of the things that I want to mention is that because of this pressure thing, bony fish can't survive at the deepest levels of the ocean.
Okay.
So down deep into the trenches and everything like that, there's a certain level where you can't really find fish anymore. But we have found fish pretty much up to the limits of what we think is possible, which is down to like basically 8 kilometers under the ocean. So this is way deep into the dark zone.
Jesus. That's literally 7 kilometers more than I've ever run.
and all the way down there, this is pretty much the limit to the point where we think that they can what's called osmoregulate, which is control their salt levels in their body.
So once you get that far down, you just like can't be a fish anymore. You just
Right.
like fucking die.
Oh yeah, basically.
Damn.
Yeah. But there are species of fish that have basically pushed that limit. So there are fish down there swimming way down there.
I'm seeing something that your bones dissolve. How does that work?
Right, yeah. So one of the things is that there's certain changes in pH and decomposition down in those very lower levels, such that there's different kinds of animals that have shells made out of like calcium carbonate and stuff like that, and they can't survive that down far either. Like their shells would basically dissolve. A lot of creatures that have these sorts of shells actually have evolved forms that are shellless and live all the way down there.
So what the fuck kind of fish can live down there then?
So if we talk about a little bit higher, so this is in the bathypelagic zone, so 1 to 4 kilometers down, you have a lot of the kind of creepy, weird fish that we think about in the dark zone, like the anglerfish,
right,
and the ghostly sea devil.
Okay.
And the ghostly sea devil's one I only found out about recently, and this dude's a real weirdo. Because, you know, at this level where you're being fed on marine snow and any of the animals feeding on the marine snow, like these little things called amphipods, which are like little clear shrimp guys. So then some fish eat those dudes or whatever, right? But at that level, you can't really have very much life. Because there's not that much marine snow, so the density is really low.
Right.
So if you're a little fish dude, you're a ghostly sea devil, you're swimming around, you find a lady ghostly sea devil,
okay,
you're going to want to bang that lady.
Right.
Because you might never find another male or female, you might never find another one again.
Right.
Right? And so what the ghostly sea devils do is the male will bite down on the female. Mm-hmm. So just kind of chomp down.
I do that.
Yep.
Yeah.
But then the next step is the weird part.
Okay.
The lady secretes these enzymes that fuse the mouth to her body. So the male can't swim away anymore. He's now a part of her. Their circulatory systems hook up, so now they're sharing blood, and then his body atrophies away until he's nothing but basically a ball sack.
Are you feeling what I'm feeling right now?
Excited?
Absolute jealousy. I'm so jealous. All I've ever wanted to do is be a scud off Stacy's body. And I'm like so upset that I have to like keep walking and living like I'm an independent person.
Yeah,
I just want to be a pair of balls hanging off my lady.
So what's crazy is that
Lucky fucking fish.
Scientists will find some of these lady ghostly sea devils
with a bunch of balls or something.
And they'll have several pairs of these male gonads hanging off because, you know, one of the males gets sucked dry and then another one will swim up and attach himself onto her and get sucked dry.
That's that's the matriarchy. That's the hand bro's tale. Republic of Gilead.
Yeah, except it's like, instead of a dystopia, it's like a utopia. Everything's better there.
All the men become scuds just living off XY chromosomes, not even complete.
So this zone, this bathypelagic zone, is also home to what are called colossal squids.
Yeah, sure, they might be giants. I know about that. The Apollo album cover.
Sure, so here's the thing. Yeah, Apollo 18.
Yeah.
I got you.
Yeah.
I got you, girl. But
it's almost like we grew up together.
but I'm not talking about giant squid. Giant squid's actually a separate species.
Oh.
These are colossal squids.
Are they bigger?
They are. A little bit bigger.
A little bit.
So these guys grow to be about 40 feet long.
It's pretty long.
Yep. It's longer than either one of us. And weighing over 1,500 pounds.
That's almost bigger than me.
So they're slightly larger than giant squids. And giant squids probably don't swim quite as deep as these guys do. These guys go way further down. But one of the things that I think is really kind of creepy and cool about these guys is, unlike giant squids, these guys, their tentacles have claws on them.
Wow.
So they can real get in there, they can scratch you up.
What the fuck do they even eat?
Right, yeah, so they'll eat some of the sort of the fish and the amphipods in the area.
Yeah, okay.
And then every once in a while, you know, like a sperm whale will try to eat them, and then they'll get into a fight about it.
Okay, what I'm curious about, so sperm whales can get down here too?
They can dive to be down here, and then they go back up.
Wow.
So they don't, like, live down here, you know what I mean?
Right.
But they can dive pretty far.
Right. Do you think whales are as smart as us?
Huh.
I like to think sometimes that they're an ancient civilization that, like, had climate change and then had to live in the ocean, and then they look at us and are like, those guys are fucking up. But, like, they can't communicate well with each other because shipping lanes cut through their cross-sea sonic communication. NPR article. Yeah, that's real. You're actually nodding now.
So we're like disrupting their communications.
Right. I mean, but mostly their phone calls are just like, look at humans, right? Just like us a billion years ago. Fucking morons.
Well, if I remember correctly,
Star Trek?
That whole group of animals were originally land animals that then went back into the water.
I think they had a whole civilization, dude. I think they're like Atlantis, and they like fucked up and like climate changed it up, and we're like, we gotta go in the ocean.
Well, maybe.
Or go into space. Again, Star Trek. Right?
Whales could be as smart as us, sure. I think elephants are probably like as smart as us.
I don't think so, man. Elephants are just like going around busting up forests. like they seem like
Episode 5.
Yeah.
Controversial.
It's callback. Anyway, so whales are from an ancient civilization. They fight with squid, who are from an even more ancient civilization.
I do think cephalopods are freaky because of how smart they are.
Yeah.
Like octopi?
Well, actually, that kind of gets me to a question, which is, how long do these squids live? Does anyone even know? Because like octopuses don't live very long, right?
Right. If I remember correctly, octopi usually live for as long as it takes for them to reproduce.
Is it actually octopi? I thought it was octopi, and then I was corrected that it was octopussies, and then I was corrected that it was octopuses because I said that too much in the aquarium.
or is it octopodes?
Octopode.
Is that what it was?
Dude, octopode, dude.
Fuck. I don't remember anymore.
Get me an octopode.
Let's just say
taco,
octopuses.
Hey.
I know it's platypuses.
Platypuses?
I know that one.
Yeah.
Anyway.
Okay, so we've got these giant skids. We got these horny female ballsack demons.
Yep.
Okay, we got the amphipods.
Yep.
What else even lives down there? Anything else, or is that basically it? There's nothing else.
So you go way down, and you can have some lobsters, you can have some crabs, stuff like that are hunting the amphipods down to
7 kilometers down.
7 kilometers down. But the deepest levels in the sea trenches. So these are deeper than deep sea vents. Like, I'm not talking about those. I'm talking about like as far down as you go, about 11,000 meters. So
wow.
11 kilometers down. At that point, you're like talking about some amoebas and bacteria and shit. You know, not very much living down there.
So they're probably on Europa too.
Oh yeah, I think so.
That's pretty cool.
I think so. I think there's life on those water moons, dude.
I think so, man.
But we're gonna get into space.
Do you remember the Amoeba Brothers from Powerpuff Girls?
No. Wait, what?
Remember the Powerpuff Girls, one of the villains were the Amoeba Brothers. And there's like 3 amoeba being like, yay! I think they're on Europa is what I'm trying to get at.
Okay, I got you.
Okay, guys, so we're going to take a break. But after a break, we're going to talk about all these vents in the deepest of the parts of the ocean. Deep sea vents, colloquially.
This is Donatello Iglesias, and right now, in a basement next door, there's an angry white guy who can't get laid, forming toxic communities that spill out into our otherwise idyllic forums like 4chan and Reddit. These involuntary celibates, or incels, are turning America into their basements, which is to say, underground male cesspools. We need to do something with these unfuckable dudes fast. Well, now you can help with My Cell. Sign up, and our adoption agency will set you up with the perfect incel. You'll Skype with them on a regular basis, periodically send a barber to clean them up, and even shoot them over basic hygienic products like deodorant and exfoliant creams for their dirty, dirty faces. You'll help push them up the stairs, out of their parents' basement, and into the wider world. These people need help. We all know that. But none of us really want to actually meet them. So now you can help these incels from a safe distance with My Cell. Sign up and save an incel today.
Okay, guys, we're back with Petri Dish. Now, Sean and I are going to talk about hot places. Places where it's so hot. Ooh, fire. Ah! We're going to talk about some deep sea vents and then some really crazy shit that blows my mind. We're going to talk about what lives on lava flows. So, Sean, take it away. Tell me about those deep sea vents.
Okay, so, in this last segment, we were talking about what's called the hadopelagic zone, which is kind of way down in the trenches and stuff like that. In comparison, deep sea vents are not that far down. They're like 2.5 to 5 kilometers down. Still far. Okay, so that's why they're still called deep sea vents, but they're not so far that you only have amoeba and bacteria there. You can have other life there too. It's definitely deep enough that you're not having light from the sun reach there. So the energy source can't be sunlight for photosynthesis.
Is it just like total ass darkness?
For the most part, it is total darkness.
What's the light then?
Right. So there's some weird chemical light that seems to be able to happen. So from these vents, these chemicals kind of shooting out into the water at very, very high temperatures. Apparently, there's a couple of photons here and there that
cool.
kind of made out of that.
And then is there like animals that like also make light that are down there? Is that like a thing that happens?
Right. So sometimes, as far as I understand, there are some of those tube worms and stuff that can produce a little bit of light.
That's cool.
But I think what's kind of weird is that there are some photosynthetic, like bacteria, that can make energy off of the photons from chemical vents, which is just very surprising to me.
So there's definitely life on Mars, because that's like crazy shit, man.
I see, but like with Mars, I don't think that there's enough liquid water. That's my problem. That's my problem with Mars.
We're gonna put it there, dude. Terraform. Right?
Yeah.
Chairman Yang. Right?
Oh, nice. Wow. Alpha Centauri. So down there, when you're not nearby a sea vent, the surrounding water is like 1 to 4 degrees Celsius. And so that's very, very close to freezing. Okay, so we're talking about cold, cold water. But then the vent water is very, very hot. Okay, so that's from 60 degrees Celsius, which is before boiling hot, but still hot, up to 464 degrees Celsius, which for Fahrenheit people, that's like 860 degrees Fahrenheit. That's hot as shit. That's way above boiling temperature.
Right. So why isn't the water just boiling?
Right. So it's because the water is supercritical. It's because of the pressure.
Do you think sometimes scientists make terms so that people will think it's cool? Like, because supercritical is pretty cool sounding.
Yeah.
And I wonder if, like, that's accidental that it's cool sounding, or if the scientist is like, I want my son to smile when I come home today. I want to tell him about supercritical water.
I'm going to go, like, 100% that direction. One of my main goals in science is to figure out something that I can name, some kind of dope-ass name.
But so we got deep sea vents. They're spouting out all this shit from the earth.
Yep.
And all these gases and all this crap. It gets so hot that the water would boil were it not for all the other things like the pressure and the salt in there. And somehow life thrives around these deep sea vents.
Right. So the life that is thriving is a little bit further away than the actual mouth of these deep sea vents because the water is coming out so hot. But you can find single-celled guys, bacteria and archaea, that are surviving pretty close to the deep sea vent where the temperatures can still be above 100 degrees Celsius. So that means that there are archaea that can survive at temperatures where water would normally be boiling inside these cells.
Wow, okay.
Which is pretty insane.
How's that even possible?
Right, exactly. They have to have these extreme adaptations to, for example, their cell membranes, which are made up of all of these lipid guys that are kind of forming this layer and everything. At temperatures that high, a regular cell membrane would just vibrate itself to pieces.
Right.
And so they need to have a chemical composition. They have different kinds of lipids in their cell membrane to keep it together, ones that are less responsive to temperature.
Cool.
And so also, the proteins that they use are organized. They're folded a different kind of way. They have a different fold structure that allows them to maintain their structure without denaturing.
Okay.
So these guys are kind of at that lower level. They're using the chemical energy to be able to grow and divide and everything. And then you have other animals come in and start to eat the bacteria, and then that starts off the food web. So then you have some guys that are eating the other ones. So amphipods and copepods are two kinds of animals that eat the bacteria, and they're munched on by snails and shrimps and crabs. And then you have some fish and octopuses and tube worms and all kinds of shit. You have a whole ecosystem from what's basically a crack in the ground.
So, these crazy guys who make energy off of the errant photon, all these archaea bacteria that make energy off of chemicals, do you think they like plastic? Because there's a lot of that down there now. You think they're down with plastic?
My guess is for those little dudes, they're more or less plastic neutral.
Sure. Like a plastic bumps into them, and it's like it's the same size as a molecule.
What I'm worried about is like maybe an amphipod, is like eating a bacteria and then eats a little bit of plastic. He's like, oh, like are these similar? And they're fucking not similar.
They're not. You stupid amphipod.
And so I feel like you can find some of these creatures where their guts just have a bunch of plastic kind of hanging out in there. And,
And then whales like eat it and shit, and they have like a beached whale.
Yep.
And then it'll be like filled with plastic and shit.
Yep. So we have these deep, hot environments under the sea, but we also sometimes have real hot environments on the surface.
Oh, wait. Shit. I had a question for you, though.
Okay, let's do the
You know
question.
how sometimes in like sci-fi movies they'll like find some frozen bacteria and it turns out they totally kill everybody?
Yep.
Do you think you could just take like a fistful of archaea from the deep sea and just like all over somebody and like gives them Ebola? Like,
Oh.
I mean, well, not literally Ebola,
Sure.
but
Yeah.
I don't know. Like, do you think there's shit that's like could be useful for us medically down there, or the opposite could like really fuck us up if like we came into contact with it?
So I think that's a good question. On the fuck us up side, I'm gonna go with almost definitely no.
It's just what's the logic there?
Right. So the processes to survive, thrive, successfully mess with us are things that our pathogens have evolved with us for a long time. And realistically, all of the evolutionary choices involved in deep sea living have just fucking nothing to do with that. So I don't think that they're well suited to anything about our bodies and would just die.
Right, like for something to infect you, your body has to, in some capacity, be a good host for it to infect you.
Right. And they need to be able to successfully compete with all of the other bacteria living on top of us and
Right.
inside of us, right?
So do you think, like, you know, in the H.G. Wells movie, like, War of Worlds,
Yeah.
where, like, some aliens come and then they die because of, like, smallpox or something?
Uh-huh.
Is that, like, unrealistic? Like, aliens would totally be fine with our diseases?
I think it's pretty unrealistic. They would need to be based on something pretty similar to us.
Well, what about Native Americans and smallpox?
Yeah, we're all human beings.
I was waiting for that. I wasn't sure how you're going to form it, but
We're all people. You're a good boy, if not, you know, like,
maybe you don't got your head on straight, Nathan, but you're all right.
I believe in your ability to turn that around. But what I will say is that, you know, I don't think we've done a ton of sampling. So when we try to grab some of these bacteria and archaea from deep sea vents, sometimes they're a little difficult to culture in labs because
Sure.
their environment is so extreme. It's hard for us to build a situation that they like to grow in.
Right.
But I will say that we've taken a lot of samples from like coral reefs and stuff. And it just turns out that they have such different metabolic pathways. They have different pathways for making different molecules. That they've made a lot of molecules that we use that are currently in the pipeline for treating different diseases.
That's really interesting.
And it's just because they have completely divergent sets of enzymes to build different kinds of molecules. I mean, it's, in a sense, you know, like cannabis making THC is a completely separate metabolic pathway that, like, corn doesn't make that. And if cannabis had never evolved to make that, we probably wouldn't have thought to make that molecule, right? So in the world, there's just all of this diversity of molecules that are made just because of the diversity in sort of life being able to make all this stuff. So there might be something in deep sea vents that could treat something someday.
So you are pro-diversity.
Yeah, I'm pro-diversity. Diversity in STEM. Hashtag.
Okay, well, that's the end of my weirdo questions. You were talking about how we don't just have deep sea vents. There's another, like, super crazy hot environment where shit can live.
Yeah, we got other hot stuff, baby. And so in this one, what I want to talk about are lava crickets. Okay, so in Hawaii, shit, I'm going to fuck this up. You want to say it?
Unininenepele.
Oh, maybe.
Yeah.
Cachynemobius fori, lava cricket, is this really weird cricket in the sense that it is the first multicellular colonizer of new lava areas.
When you say new lava areas, we're talking like it erupts, a volcano erupts on Honolulu, and like the lava flow, and like crickets just hopping around.
I mean, pretty close. So about 3 months after a volcanic eruption, this is still before there was any plant life in that new volcanic area. Okay, so we don't have any, you know, there's not like little sprouts coming out all
Right.
beautiful like yet.
It's just like some fucking rock.
It's rock and it's some sea foam, you know, like the kind of the sea foamy shit.
How do you get that there?
Wind, basically, right?
Okay.
So on the ocean, you have sea foam, which is basically kind of protein products from like plankton and shit. And it just sort of gets all riled up on the ocean and blown over onto the island.
That's cool.
So you have sea foam, you have lava rock, and you have crickets.
Okay,
And
crickets.
You have these little cricket fucks running around. These crickets don't have wings, so they don't even get to sing to each other. The little mute crickets.
That's the saddest shit you've ever said to me.
And they're running around and they're eating sea foam,
The hell?
and any decaying plant matter that might have blown in on the wind.
Okay.
So they're just eating like just stuff that is blown in on the wind. Because there's no other real life here yet.
And there's also nothing else to compete with them for whatever meager resources there.
Yeah. So they're just hanging out. They're eating that, but there's not a lot of resources. So when the females get pregnant, they go ahead and drink the blood of their mate in order to get some sustenance out of it. So this is another situation where the lady is sucking the man dry.
Everyone is... I'm so jealous of it.
Yeah, it sounds like the good life. So by the time you do have plants come in, because eventually plant seeds will blow in,
Right.
you'll have little dudes
And
sprouting.
then the crickets must be really happy because now they have more food.
Crickets are gone.
They're just gone?
They're gone from the ecosystem.
Where do they stay?
We don't know.
Did you ever see the movie Moana?
No, I haven't actually.
That's
but you've
crazy.
referenced it like 7 times.
You would love it. It has so much stuff about coconuts. I don't know if you guys know this, but Sean loves coconut shit.
I am crazy for coconuts.
Yeah. Coconuts. So Sean loves coconuts, and the movie Moana is like mostly about coconuts.
Okay.
It's about how this girl creates a coconut raft to go save the heart of Tafiti. And the reason I'm getting to this is because I know those crickets must be the spirit of the heart of Tafiti, coming to save the Hawaiian people and whisper to them secrets of climate change.
Holy shit.
I'm just saying.
What the fuck was the point of all of that?
How can science explain these crickets? Like, where do they go?
It's hard because we really don't know where they are in the rest of the time. We really don't know. We don't know where they're hiding because basically the only time you ever see them is for this brief period 3 months after the eruption, but before the plants are growing. You know, maybe 3 to 6 months after that. Right?
I think they crawl back into the volcano and like talk to their lizard masters.
Maybe they are firewalkers. It's possible.
That's what I think so, man.
I saw that X-Files episode.
Yeah, dude.
That's right.
Season 2.
But it's mysterious as shit. So if you are a budding entomologist, maybe you're going to be the kind of jamoke that goes over to Hawaii every once in a while when there's a volcanic eruption.
That's a very pointed thing for Sean to say because he knows that I wanted to be an entomologist and that I failed in my life goals.
Oh, you could still be an entomologist, baby.
Stop teasing me. Okay, let's take a quick break. And then after that, we're going to talk about the exact opposite kind of crazy environment. We're going to talk about cold places and how extremophiles live in cold places.
Hey, folks. Studies have shown 93% of grandchildren are self-centered little shits that can't be bothered to send so much as a text to their doting grandma or grandpa. Yes, dear listener, I'm talking about you and me. We are all those shitty grandkids. Well, if you feel any semblance of guilt or propriety, sign up for With Love, a service that periodically sends your grandparents letters, flowers, and little tchotchkes in your name. Finally, rest easy at night knowing the most basic of familial obligations have been met. Reclaim your spot as the favorite grandchild with Love.
Okay, guys, we've talked about deep under the sea. We've talked about where it's hot. Now we gotta talk about where it's cold. And Sean, if I remember correctly, this is a subject that we've kind of broached already with some funky guy.
Right, so in our sort of evolution-y kind of episode, we talked about the Antarctic rockfish, which is the one that has those antifreeze proteins. And, I mean, that shit was really cool. That guy's underwater, and the water there is a little bit below freezing, but because of the salt content, right, it's still liquid.
And they make their own antifreeze to survive.
Right, and those temperatures, we're talking like 28 degrees Fahrenheit. Okay, so like that's cold, but like, I mean, I don't know, there's people walking around at that temperature, right? But there is an insect called the wingless midge.
Isn't that just a vagina?
What?
Midge. A midge.
God damn it. Holy shit.
Okay, so there's some like weird bug vagina.
Yes.
That was found by Japanese men. That's why it's called a wingless midge. Leave it to them. Up in the Himalayas.
Yes. So there are some Japanese scientists that were hanging around the Himalayas. And the temperatures we're talking about here is like negative 15 degrees Celsius. So that's about 5 degrees Fahrenheit. So that's a cold day.
That's not that cold.
That's a cold day. I was in Chicago for a little while.
I was about to say, that's just like a summer in Chicago.
No, that's winter in Chicago. But Like, it would definitely be that cold. It's just you'd have to bundle up a lot, right?
Sure.
But these insects,
There's
they're
like a
they're
lot
not
of
bundled
wingless
up.
midges walking around Chicago at 5.
Yeah, these guys, they're not wearing a coat. Okay, they're just walking around, the little insect cells. They're not even endotherms, so they're not warm-blooded, right? They're just insects that are basically the same temperature as the rest of the environment.
That's pretty fucked up.
But they are walking around.
Do they have an antifreeze that they create?
So as far as we can tell, they probably have something kind of like an antifreeze protein that's making their insect blood
Not freeze.
not freeze.
Okay.
But it's probably also part of it is that it's a very concentrated liquid.
Are there like more things living in the Himalayas than I knew? Like, what do they eat?
Right, yeah. The adult form of the wingless midge, which is the one that's crawling around on the surface.
I only like adult midges. Okay.
God, Nathan, God damn it. God damn it. The adult midges don't eat anything.
So what do these guys eat?
Yeah, nothing.
Nothing.
Adult midges don't eat anything. The larval state of the midge lives kinda under the snow in these sort of snow melt areas where there's a little bit of this running water, there's some bacteria growing, and so they basically munch on bacteria, but then once they mature into the adult form to bang each other, they stop eating.
You know, that's actually really not rare for insects. There's plenty of flies and moths that are like that.
Right, yeah, so it is, I guess relatively common for the adult form to be just about banging.
And there's a lot of monks like that. But like the opposite.
Yeah, they stop eating so they don't bang.
Yeah.
Yep, I got you. Pretty much the other way around.
Okay, so that's pretty cool. So you have a bunch of like insects that are just hanging out. It's super cold, and yet they kind of make it by only existing to fuck.
Yes. I mean, the larvae are still living in a pretty cold environment. It's still the Himalayas. Right? But the adults are the ones living on the surface where the temperatures are lower. And, actually, this sort of genus, this family of insect, these wingless midges, are actually also found on Antarctica. So they are an insect species that lives there also. It's just the temperatures are a little bit lower on the Himalayas, actually. Mm-hmm. So that's why I brought up the Himalayas, is because it's actually colder and more impressive.
What eats them?
Not much.
So it's just kind of like free reign. If you make it as a wingless midge, you just like, sky's the limit.
Yeah. So you get to run around, bang, and then die because you didn't eat anything.
I mean, that's... What are we, if not that?
You like eating. Don't try that. But,
okay, what other cool thing is there?
Yeah, so one of the other things I want to talk about, in a certain sense, is a little less fun. I've been trying to avoid talking about extremophile bacteria and archaea because most extremophiles living in like super salty environments or super hot environments, like most of those dudes are archaea. I wanted to try to talk about kind of bigger animals. But this one I wanted to mention just because of how weird it is and how much it surprised me. There's a lot of bacteria that can keep existing at cold temperatures, right? So like, your freezer, you can put something that has bacteria on it into the freezer, and a lot of times the bacteria won't die, they just won't grow anymore. Basically, what happens at these cold temperatures is some bacteria will die at cold temperatures, ical form, but then other ones will go into kind of a dormant state, okay? And one of the things that made scientists think about is, how dormant is this dormant state?
Yeah, so why the fuck can't we do that?
Right, so part of the problem is that we have all kinds of organs and tissues that have differentiated to a lot of different roles. It's difficult to come up with a solution for all of them to get sustained in a dormant state properly.
Right. It's like you take a homeless guy and just throw him walking down the road. He's going to have an easy time because that's just his life anyway. But if you took like a really fancy rich person and so you just threw him on the road, they'd probably die pretty fast because they have all this fancy stuff, all this accoutrement, and they don't know how to live without it anymore.
I guess it is kind of like that.
Yeah, I'm a communicator.
That was actually... I was so worried when you started out.
You should still be worried.
that was better than I thought it was going to be. So
I'm right.
Yeah, let's go with
We're like the fancy rich person.
Yes. Yeah. Yes, we are the fancy rich people to the homeless bacteria. But the thing is that over time, if you're just in a completely dormant state, your DNA is going to start breaking down.
Right, we've kind of talked about this. You just can't escape radiation. You can't escape UV. That's what's going to hit your genes and shit and just break shit down.
Yeah, and even in conditions that are more or less frozen, you can still have a little bit of molecular motion that over time, over thousands of years, you'll start to see this breakdown of DNA. And so this is one of the reasons why we probably can't do Jurassic Park shit, is because millions and millions of years is too long for DNA to not have broken down.
And if you put the frog genes in there, they breed.
Yes, life finds a way.
Life finds a way.
Yeah, and so does Jeff Goldblum.
I was about to say Jeff Goldblum, dude.
He's very sensuous.
Can't find a way into my bed pretty easily.
But so basically, over time, like, let's say 100,000 years, the DNA that you have is going to be pretty much broken up all to shit. And so if you have in like the tundra or something, if you drill really deep down into the ice or whatever,
You'll find Putin's enemies.
yes, they've been buried for a long time, and the bacteria on his enemies have been in a dormant state. But if you thawed them, they probably won't come back to life, because if they've been down there for 10,000 years, 100,000 years, their DNA is too broken up. They can't recover.
Okay, so basically, game over, GG. You can't have bacteria for more than 100,000 years.
Yeah, unless you don't go 100% dormant.
Okay.
Unless you remain semi-awake and keep repairing your DNA.
Right, like Walt Disney.
So they have found, they took some permafrost. Okay?
Okay.
From Walt Disney's frozen head.
Right off the forehead.
From the tundra, they've got this permafrost that drills down far enough to go back 500,000 years.
Okay, it's pretty long.
And they've found fully intact DNA from bacteria that have been, for 500,000 years, repairing their DNA that entire time.
Okay.
So they've been sitting down there in the ice, repairing themselves, waiting for their chance to thaw out.
Huh. Yes. That's pretty cool.
Yeah, dude.
And some scientists went and fucked it up.
Yeah, so basically, that's a really incredible finding, because that means that there is something that, by kind of, the criteria of being alive, has remained alive for 500,000 years in completely frozen temperatures, deep underground in the permafrost, and has just been chilling and biding its time and being awake enough to repair itself.
Jeez.
Which I think is another
What do you
X-Files
think
episode.
they dream? Do frozen bacteria dream of anaerobic sheep?
You're very cute. You're very
I'm
cute,
so
boy.
cold, shit.
And so, the kind of the ability of life to keep existing in an environment as inhospitable as that,
It makes you wonder.
It segues us
Yeah.
into space.
Space! What could be colder than permafrost? The vacuum of space itself.
Yeah, and my heart.
And your heart. Well, let me warm up your heart with this cool. Let's talk about space. Let's talk about space.
What the fuck happened there? Was that supposed to be a transition?
So there's a South Park episode where
Shut your whore mouth. Let's just take a break, and then we'll talk about space. Hey, welcome back, you guys, and we're going to talk about space. Space. Yeah, so, I think...
nothing lives in space. No one can even hear you scream. So why are we talking about space?
Well, because as we, SpaceX, as we start popping stuff up out there into outer space, I think it's worthwhile to discuss all of the things living on Earth. Is there anything that can last out there in the vacuum of space? And then
Elon Musk.
also, based off of some of the extreme environments on Earth, is there anything that we can guess about potential life in other places?
Sounds to me like a lot. Like all that deep vent shit, all those lava crickets, all that shit you could just throw on Venus.
Right.
Yeah.
Yeah, I agree with you. Sure.
Okay.
So, to begin with, let's talk about some of the things that can hang out in the vacuum of space.
What?
For at least a little bit.
Okay.
One of them is water bears, or tardigrades. You know about these little guys?
Are they like related to sun bears, or like how big are these bears? I don't think they're American, right?
They're very small. You can see them under a microscope. They eat bacteria.
Well, you could see a normal bear under a microscope. No. You just only see part of it.
A really small part. For these guys, you can see the whole thing when you're looking under a microscope. So they're microscopic dudes, and they're crawling around. They're all over the place, but a lot of times they like to live in ponds and lakes.
Oh, okay.
And they kind of swim around.
So they must be really permeable. They must not be able to live outside of their environment. Like, they must be pretty fragile, right?
So, what's crazy about these guys is they can enter into a state, kind of like a bear hibernating.
Okay.
It's called the ton state.
Just like a bear.
I guess so.
So the Eskimo people
And
call
it's
it.
this kind of like stasis state where basically they seem to be able to kind of relatively dehydrate themselves. And what that does is it makes them really hardy to a lot of situations that would kill the shit out of a lot of other organisms, definitely humans included.
It's like how Egyptians would turn themselves into mummies so they could reawaken 7,000 years later.
Right, and mummies are pretty hard to kill.
Yeah.
I feel like.
Yeah.
And, so are tardigrades.
I saw that movie.
Mummies in space.
Mummies
That's what
in
this is
space.
about. So one of the things that they can do is they can handle insane pressures. So they can handle pressures that are like 6,000 times the gravity on the surface of the Earth.
What is that vis-a-vis the deep sea?
Which
is more pressure?
Tardigrades would be able to survive, or in this stasis state, they would not be crushed by deep sea pressure.
Okay, that's pretty cool. Okay.
And they are able to survive in the vacuum of space. So on the opposite end of the pressure spectrum,
Jesus.
they can remain in the stasis state. And there's a recent story about a batch of tardigrades that got crash landed on the moon. You hear about that?
Yeah, I think kind of, yeah.
Yeah, there's some dude who wanted to send a colony of these like ton state tardigrades. So they're just on the moon now. They're probably going to hang out there for a while. They're not awakened, right? But if we ever accidentally toss a little water on there, or like maybe a comet, like part of it hits the moon, gets a little bit of water. If it turns liquid, it could wake up those tardigrades and they could be hanging out.
I think they'd be real mad. Like suddenly on the
They'd be
moon.
like, what the fuck is this?
No!
Yeah, but maybe they could, set up a forward base for us or fight the moon Nazis or
So
whatever.
that's pretty crazy. So there's these water bears that can just like live in space. Well, not live in space, but they can hibernate and stay alive in space.
Right, and so this is kind of a trend in that, so far as we can tell, there's really nothing that can have a good time in space, that can divide and be kind of actively growing in space.
But there's stuff that can bide their time to hopefully get somewhere else through space.
Right, and one of them is actually also very common. It's black mold.
So that's the kind of shit that was like Hurricane Katrina, your house is, it's wet, black mold grows on them.
Yeah, and like the International Space Station.
Okay, let's build that out. What are you talking about?
And in the space station where the astronauts are hanging out and everything, there's like black mold growing there that they have to like deal with.
Wait, is black mold's name Asperger's niger?
Aspergillus niger.
Niger, okay.
But yeah, well, that's the black part. Black mold.
Controversial.
It's not racist.
Okay, so that was growing in the ISS?
Yeah, it still is.
It still is?
Yeah, it's like a constant problem.
We need to help them.
Yeah, I mean, it's not great. It's not great. But, in that case, it's mold spores that got carried kind of in the components and everything for the
Jesus,
space station.
dude.
But some scientists were like, okay, but can black mold survive outside of the component? On the outer side of a spaceship or something like that.
So they like reached out and slapped some on the side?
So they did a series of tests in a lab to expose them to different kinds of environments that they thought would be similar to what a spaceship would go through.
Okay.
And so one of those tests that they did was they used radiation. So they shot radiation at this mold, right? And so radiation is measured in this unit called a gray.
What?
And
Why?
it's like a person's name.
Oh, okay.
It's like the dude that made this measurement system.
Was named something gray.
Yeah.
Okay.
Something gray. And it's about how much energy is getting absorbed by whatever you're shooting the radiation at. So humans start to get radiation sickness at about half of 1 gray. Okay? And you pretty much die at 5 gray.
Okay, that's a pretty small number.
Yeah, right? And so to get radiation treatments for cancer, you get really targeted doses of like 20 to 40 gray.
Wow, okay.
So it's not over your whole body, it's over a very specific part.
So you're really killing the shit out of that.
You're trying to.
Yeah.
And for an X-ray picture, you're getting a dose of like 0.0007 gray.
So like just a little tingle.
Just a little bit.
Little
right?
zhuzh.
And if you're on a spaceship and you're flying out there, on the outside of the ship, you're getting hit with about 0.7 gray.
Oh, that's pretty troll.
And on the surface of Mars, you'd be getting like 0.2 gray.
Wow.
Right?
Okay, so Mars sucks.
Well, I mean, if a person is hanging out on Mars, they will eventually get radiation sickness and be very bummed out. That's for sure. It doesn't have enough of an atmosphere.
We're from Manhattan Beach. It's like true of going out anyway.
I mean, those are some of the UV rays that we're getting in Manhattan Beach, but these are like fucking X-rays and shit.
Sure.
Anyway, so they took these mold spores and they blasted them with from 200 to 1,000 gray.
Jesus, that's
Okay.
like 7 Fukushimas.
Right, so to remind you, cancer gets about 20 gray.
Okay.
These guys, on the low end, we were shooting them with 10 times more radiation than cancer gets.
On the low end.
On the low end.
Damn.
And we went up to 1,000 gray. And then we took other spores and we shot them with UV rays, many, many times more than what they'd be getting in outer space. And what we found out is that the mold spores survived that shit.
Wow.
The mold spores survived UV radiation 10 times greater than what we use to sterilize stuff.
How's that even possible?
Yeah, so what they do is they build this kind of outer capsule for their spores that have a lot of pigmentation in them. And the pigments will actually get hit by these rays coming in.
Oh.
And will basically get destroyed by those rays, but they'll kind of absorb the brunt of the damage.
All the good stuff in the middle that actually matters doesn't denature it.
Right,
That's
like
all
the
safe.
DNA, that all stays safe. Right, exactly. So these spores are extremely hardy, and that means that like the sterilization with UV rays that we might do on spaceships or components that we want to send into space on like a mission to Europa or something.
Yeah.
We might not kill all of the mold.
Wow. I mean, when we even, the opposite, when we want to like smear the outside of the rocket with like extra mold.
Only if we're trying to seed that planet with life from here. But
Sounds like this shit's going to happen anyway.
well, but like, look, here's the thing.
Aren't we seeding our lives on that planet?
Eventually. But first, wouldn't it be fun to know if there was like life on there from that planet? See
But
what
then
that's
we
like?
feel guilty when it's dead. Imagine how much better we'd feel as Americans if just like there was nothing here when we came.
Well, I mean, part of this story makes it seem like no matter what we do, there's going to be mold spores on there, so that might be the end of the story anyway.
Just exploit, John. Don't worry about
I don't like it.
it. Okay, so why can't we just paint ourselves with 4 layers of pigmentation and just like hang out in space? Like why can't we like make this pigmentation in a lab and then like replicate it?
Well, so I mean, as far as I understand, the spores in Aspergillus niger actually do have melanin in them, or a chemical similar to melanin.
That's cool.
So I think actually, in a certain sense, having darker skin, tanned skin, is supposed to be helping for like the UV side of things.
That's cool.
Right? That's kind of the whole point of that, is to
Right.
be absorbing that UV radiation.
It's like when you see like hot older moms in Manhattan Beach, but their skin's all damaged.
Yes.
And you're like,
Wear sunblock.
yeah.
Seriously. If you want to be hot in like your 60s, you're going to have to protect your skin.
Yeah, it's like you just want to take these ladies aside and be like, look, I get it, you're hot and you're blonde, but like sunlight doesn't care about that.
It's not just the ladies.
That's true.
I've seen a
Well,
lot of
yeah.
really sexy dudes, but then you know what? They start getting them
Just
wrinkles.
like withered.
Yeah.
It's
We're
like
actually we're gonna have a skin episode in the future.
Really?
Yeah, because I think that we have a lot of stuff to talk about with skin health and everything.
We need to get into that Korean market.
Right.
Yeah.
Exactly. I know somebody who does research.
That's cool.
In skin and like hair follicles and stuff like that. Actually, shout out to Matilde. And so I think we're going to be able to get her on, and we'll be able to basically have a discussion with her about it.
That's cool.
But in any case.
So we're taking mold to Europa.
Unfortunately.
Yeah.
But it would be nice to get to check out some places like Europa, because basically the idea with Europa and one of the moons of Saturn, for example, is that there's this layer of ice on the outside, but underneath that ice, we're pretty positive that there's liquid water.
Cool.
And the way that the heating system kind of works with sort of the push and pull on the interior, the core of the moon as it goes around Jupiter and Saturn, the gravitational pulls create this kind of tidal force that generates heat.
Okay. So what we're saying is that a lot of the extremophiles that we've surveyed, these might be the sorts of things that prime us for the organisms in the broader outer space.
I mean, with outer space, we don't know if they're going to have DNA or RNA or anything like that. We're not totally sure what they're going to look like.
Right.
But things that live on Earth could hypothetically live on those moons. And we might find some shit there someday.
That's pretty cool.
Although I don't know how we're going to do it exactly. Because the ice thickness is like way thicker than any ice that we've ever drilled through. So I'm not actually sure how we would get down to them.
Sure,
exactly.
there are like logistic steps between now and us going into Europa's underwater oceans.
Yeah. Plus, like, a trip to Mars takes, like 6 months or something like that. Like,
Yeah,
and
that
these
sucks.
guys are way out past the asteroid belt. I don't even know how long it would take to get there on a
Jesus.
spaceship. But in any case, there might be life out there. I'm optimistic about it.
And like, who even gives a fuck about Europa when we've got so many cool extremophiles here
That's true.
that we still don't really properly understand?
You know, as scientists, we've only surveyed a fraction of the life that currently exists on Earth. And then there's a good chunk of the life on Earth that's going to die out before we ever get to see it.
Nah, don't
But
think about it.
with any luck, you know, things will still be alive and kept around, and we'll be able to learn more and more new stuff and new extremophiles.
You know, I used to be really bummed that I knew I'd never try all of Popeye's chicken specials before they ran out. But then I just came to peace with that. And listeners, you should come to peace with the fact that most animal life we're never going to know about before it's dead. That's just how it is sometimes.
Oh, man, Popeyes. Okay. So, I think we're good. We're going to close this guy out?
If you guys sign up for our Patreon at Petri Patreon.com/.
How do you still not know that? Patreon.com/Petri Dish.
If you guys sign up, you're going to get some free Popeyes from Sean. Okay, we're riding this Popeyes chicken special wave.
Wow.
Okay.
Okay, you can follow us on Twitter at Dish Podcast. I'm now the social media manager, so if you message at me in Twitter, then that's literally just going to be me having to deal with whatever shit you just said to me. So, be nice, but you can do that. And you can email us at petridishpod@gmail.com.
We want to thank Stacy Song, our sound lord, for engineering all things sound. And we want to thank Brian Allen, as always, for the art and, 50% of our genetic material.
Yep. And thank you, listeners, for checking us out, and we hope you enjoyed the episode.
Stay extremely philic, guys.
Damn it.
Stay extrophile.
Fuck.
Stay extremely file. Woo! Outro music.
All right.
Da 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 da.